Programma 101.
The Programma 101, also known as Perottina, was the first commercial desktop computer. Produced by Italian manufacturer Olivetti, based in Piedmont, and invented by the Italian engineer Pier Giorgio Perotto. It was launched at the 1964 New York World's Fair. Volume production started in 1965. A futuristic design for its time, the Programma 101 was priced at $3,200. About 44,000 units were sold, primarily in the U.S. It is usually called a printing programmable calculator or desktop calculator because 3 years later the Hewlett-Packard 9100A, a model that took inspiration from the P101, was advertised by HP as a portable calculator, in order to be able to overcome the fears of computers and be able to sell it to corporations without passing through the corporate computer department. Although, the concept of stored program allows this machine to be considered a true computer.
Capabilities.
The Programma 101 was able to calculate the basic 4 arithmetic functions: addition, subtraction, multiplication, and division, plus square root, absolute value, and fractional part. Also clear, transfer, exchange, and stop for input. There were 16 jump instructions and 16 conditional jump instructions. 32 label statements were available as destinations for the 32 jump instructions and or the 4 start keys, B, W, Y, Z. Each full register held a 22-digit number with sign and decimal point. Its memory consisted of 10 registers, 3 for operations, M, A, R, 2 for storage, B, C, 3 for storage and/or program, assignable as needed, D, E, F, and 2 for program only, P1, P2. 5 of the registers, B, C, D, E, F, could be subdivided into half registers, containing an 11-digit number with sign and decimal point. When used for programming, each full register stored 24 instructions. It printed programs and results onto a roll of paper tape, similar to calculator or cash register paper. Programming was similar to assembly language, but simpler, as there were fewer options. It directed the exchange between memory registers and calculation registers, and operations in the registers. The stored programs could be recorded onto plastic cards approximately 10 cm x 20 cm that had a magnetic coating on one side and an area for writing on the other. Each card could be recorded on 2 stripes, enabling it to store 2 programs. All 10 registers were stored on the card, allowing programs to use up to 10 stored 11-digit constants. The program to calculate logarithms occupied both stripes of one magnetic card.
Construction.
All computation was handled by discrete devices, transistors and diodes mounted on phenolic resin circuit card assemblies, as there were no microprocessors, and integrated circuits were in their infancy. It used an acoustical delay line memory with metal wires as a data storage device. Magnetostriction transducers inside an electromagnet attached to either side of the end of the wire. Data bits entering the magnets cause the transducer to contract or expand, based on binary value, and to twist the end of the wire. The resulting torsional wave moved down the wire. A piezoelectric transducer converted the bits into an electronic signal that was then amplified and sent back to the beginning with a delay time of 2.2 milliseconds. Typically, many bits would be in transit through the delay, and the computer selected them by counting and comparing to a master clock to find the particular bit it required. Delay line memory was far less expensive and far more reliable per bit than flip-flops made from vacuum tubes, and yet far faster than latching relays.
Design and ergonomy.
Olivetti was famous for its attention to both engineering and design aspects, as the permanent collection at the Museum of Modern Art testify, and the Programma 101 was another example of this attention. Engineering-wise, the team worked hard to deliver a very simple product, something that anyone could use. To take care of the ergonomics and aesthetics of a product that didn't exist before, Roberto Olivetti called Mario Bellini, a young Italian architect.
Interaction design and usability.
One of the direct results of the Programma 101 team focus on human-centered objectives was the invention of the programmable magnetic card, a revolutionary item for that time, allowing anyone to just insert it and execute any program in a few seconds. It was a very portable and effective solution, a small magnetic strip with a program memorized in it and a space on the other side to write the description. The program was loaded just by inserting the card at the top, and when the card came out at the bottom, it was aligned perfectly with the V, W, Y, Z keys in a way that the author could have written on the card the labels for these buttons, to make the user aware of their new function.
History.
It was designed by Olivetti engineer Pier Giorgio Perotto in Ivrea. The styling, attributed to Marco Sanuso but in reality by Mario Bellini, was ergonomical and innovative for the time, and earned Bellini the Compasso d'Oro Industrial Design Award. Developed between 1962 and 1964, it was saved from the sale of the computer division to GE thanks to an employee who one night changed the internal categorization of the product from computer to calculator, leaving the small team in Olivetti and creating some awkward situations in the office, since the building except that office was then owned by GE. The Programma 101 was launched at the 1964 New York World's Fair, attracting major interest. 40,000 units were sold. 90% of them in the United States, where the sale price was $3,200, increasing to about $3,500 in 1968. Hewlett-Packard was ordered to pay about $900,000, $6.74 million in present-day terms, in royalties to Olivetti after copying some of the solutions adopted in Programma 101, like the magnetic card and the architecture, in the HP 9100. About 10 Programma 101 were sold to NASA and used to plan the Apollo 11 landing on the Moon. The 101 is mentioned as part of the system used by the U.S. Air Force to compute coordinates for ground-directed bombing of B-52 Stratofortress targets during the Vietnam War.